Thanks everyone for coming. I know it's towards the end of the day. So my name's Ben, and today I want to talk about minimum viable migrations as a path to adopting serverless. As I said, my name's Ben. I run a company called Alios, which is a consultancy helping people adopt serverless, unsurprisingly. And that's typically startups who are building an initial product to scale quite quickly, all the way through to sort of global enterprises moving away from things like on-prem or maybe lift and shifted. They now want to move into more sort of a cloud-native approach. I'm also an AWS serverless hero, so I speak at a lot of conferences and work with AWS on sort of the product roadmap for some of their serverless services, which is really fun. So I spend a lot of time in the serverless community and say serverless way too much. So in terms of what we're going to look at today, we're going to look quickly at what is agile. I'm sure everyone in the room knows what agile is, but I just want to remind us before we then look at cloud migrations and make a little bit of a contrast in terms of how that's looking. I then want to look at why cloud migrations maybe are not approached in such an agile way and how minimum viable migrations can be a framework to help us take a more agile approach to migrating to cloud native technologies like serverless. We'll also have a quick look at domain-driven design and event storming. I know Bob Gregory touched on it a bit earlier, but how that can help us build a set of events which can then allow us have a sort of minimum viable migration approach to our migration. And finally, we'll look at injection strategies for our MVMs, our minimum viable migrations, and how eventification and anti-corruption layers are needed to help us on this journey. The last piece we'll look at is how we're going to build a roadmap of MVMs. So how do we prioritize what we migrate first, and how do we sort of sequence the different launches of MVMs to gradually strangle our existing application. And finally, we'll look at some conclusions and bring it all together. But firstly, what is agile? I'm sure I'm talking to all of you about something you know before. But it's about discovering requirements, it's about collaborative efforts, it's about cross-functional teams, and it's about involving the customers or the end users. And going hand in hand with agile, people often talk about minimum viable products, which is where we launch an initial product with just enough features to be usable by some early customers to provide feedback for future product developments. And I think if I asked most of the engineers in this room, we're going to go launch a new startup, the Uber of Airbnb or whatever it might be, we'd take an MVP approach, we'd build something greenfield, we'd build something small and gradually add to it. But when it comes to cloud migrations, it ends up being a little bit different. And we lose out on the benefits of agile, but also the MVP approach. With an MVP, we test our hypotheses earlier, we learn much faster, we reduce waste, we ship value to our customers more quickly. There are some other advantages. But with a more migration-based approach, which typically falls back to more waterfall approaches, we don't get any of these benefits. So now we're going to forget agile, and we're going to go into the world of migrations. So what is a cloud migration? Well, a cloud migration is the process of moving a company's business assets and operations to a cloud provider, or maybe from one cloud provider to another cloud provider. And for me, it's really a shift in domain, from domain A through to domain B, which might be a traditional cloud migration, a lift and shift from on-premise to cloud. It could be a language migration from .NET to Python for some reason. It could be a more structural migration, taking a monolith and gradually restructuring it into microservices. Or my favorite, it could be taking an application that may have been lifted and shifted into the cloud and then restructuring that into a fully event-driven serverless architecture. But does this sound like any of those migrations? Discovering requirements through collaborative efforts, cross-functional teams, and involving the customer with releasing just enough features to provide feedback. Typically for me, I don't see migration projects going that way. They typically are a more waterfall approach where there's a lot of requirements gathering, there's a lot of design, there's implementation, verification, and then a really big bang release. If you're very unfortunate, procurement comes somewhere in the middle and doesn't necessarily speed things up. But even if you don't have procurement in the middle helping, you really have a more waterfall approach to migration projects because people think they know the requirements. They have their existing system, we know all the requirements, rebuild it, let's do a big bang release, and then let's turn the old system off. And there's a good reason for this. If we have two systems, a system as is and a system to be, and we're building our new system, we have an existing set of features. In this matrix, you can see features like SSO, email, core feature X, legacy feature Y. A 1 represents it existing in the architecture, a 0 means it doesn't. You can see in the as-is system, the system we already have, well, we have all the features because that's where we've got to. But in the new system we're about to build, we don't yet have all of the features. And this leads to what I call feature parity paralysis. We have a new application in the new architecture with some of the features, but not all of them. How do we ship if we don't necessarily have all the features of the existing system? Now, if it's a legacy feature that's maybe not used by everybody, there are a few things we can do to work around it. We could run an opt-in program where some users choose to move to the new version of the application because it's faster, because it's more reactive, because maybe it has some additional features, but they know they're losing out on some legacy features they may not be using. We could remove features entirely. Maybe they're not generating a lot of revenue for the business. Maybe we need to force people to move away from their SMTP uploads that they may be using rather than the new and improved form system that we've built. And we can actually identify user segments from analytics that are not using that legacy feature and migrate them automatically. But how do we handle high priority systems? If we have a core feature, let's say we're rebuilding Uber and you can't actually pay for your trip, well, that's a core feature. How could we possibly release without it? Well, we can't. So we need to have two systems running in parallel if we're going to be more iterative rather than have the big bang release strategy. But how do we plan this? How do we avoid the design of the old system impacting the design of the new system? How are we going to communicate between the two systems? And how do we plan and phase the migration? And this is where the framework of minimum viable migrations comes in, and it's something I've used with many different companies of very different sizes to migrate in a more agile way to adopt serverless. Now, a minimum viable migration is a usable migrated version of an application from one domain or paradigm to another with a subset of features to be used by some or all customers. You can really see the link to minimum viable products, but here it's how do we release with just enough features for a segment of users or to redirect some parts of the application to the new architecture. Now, for those of you familiar with the strangler fig pattern, this is all very familiar because it's very much the strangler fig approach. But the MVM framework is sort of a step-by-step guide for approaching a strangler fig modernization. And each MVM, each minimum viable migration, is really a stepping stone in that journey from the legacy system through to the modernized application. So why do we use minimum viable migrations? Very similar to why do we do MVPs. We learn faster, we test assumptions earlier. We're going to be adding a lot of new technology in the new system. Maybe we're assuming it's going to scale. Maybe we're assuming its cost is going to be good. Maybe we're assuming our existing engineering teams are going to be able to build and run with it. And it allows us finally to focus a team on a culture of continuous delivery. When people are moving from a legacy application, they're often moving for a reason. Maybe it's part of a wider digital transformation, but they're often moving to get things like a higher release cycle, greater experimentation. If the actual project to migrate itself has a huge release cycle of 12 months, 18 months before the team actually releases the first version, that creates a paradigm where the teams are not releasing, not using CI, and not moving to that continuous nature. So being able to split into small MVMs, which might be 8 weeks long, we can actually start to build that culture of delivery through the migration to set us up for success after we've migrated. And one piece which I skipped over was it delivers value to customers earlier. Maybe we're migrating, but as we're migrating, we take the opportunity to have much better performance or add Apple Pay to the payment page. We can start to ship some of the benefits of the new technology as we migrate, rather than waiting for after the Big Bang release and then finally reaping the rewards when the world's probably changed quite a lot. So if we rethink our two domains, our as-is and our to-be, and we think of three key features, feature A, feature B, and feature C. And we see these two systems working in parallel. At the minute, all the features are in the as-is system. Over time, we're going to start rebuilding these features in the to-be system, which means gradually we're going to strangle that existing system until there are no features served by the existing system, and we can turn it off. And in parallel, we're obviously building up the features in the new system as we start to retire them from the old system. But this all requires communication and a set of progressively evolving systems between. System as is, system to be, and many steps between. And of course, technology keeps changing. It's not like one day we're going to turn it off. If we build this migration path in the right way, that system to be can keep moving forwards as technology moves forwards, and we can have quite an evolutionary architecture. So it looks easy. Well, there's actually a few requirements to be able to do this. You need a defined list of events and a schema from the business domain. Now, event-driven architectures have many benefits, loose coupling, lots of other things people have talked about in other talks, but events can also be our mechanism for the migration. If our channel of communication in the new system is event-driven and based off domain events, so not technical events, but events from the business domain, that means that we will have a way to convert the legacy system's signals, or whatever request that it's doing, into the events that are the interface between the systems, between the services of the new architecture, because they're based on the underlying business domain. we're going to need an event communication, an event broker, something like an event bus in the new system, but also the ability to emit events from the old system into the new system. That's eventification, which we'll talk about in a minute, and the ability to react to events from the new system in the old system. And that final piece, it depends on the architecture, it depends on the constraints you're working with. So really, we're building an event-driven architecture, which means we need to think in terms of events. Now, Bob Gregory gave a really good talk about domain-driven design, and event storming is really an extension of domain-driven design. And I want to talk about it for a moment because this is how we derive our set of events from the business domain, which will be the interface between the services, the event-driven services of the new architecture, but also our communication channel with the legacy. Now, as I mentioned, event storming is an extension of DDD, and it's a really lightweight way to try and discover a domain. It's going to discover our events, order placed, item dispatched, our entities, customer, seller, our bounded contexts, which I won't go into too much detail today, but are rough sort of groupings of areas of the domain. And for us, that's the key sort of stepping stone to move in to our event-driven architecture because we get that defined list of events. Now, for those of you who've done event storming before, it's quite a chaotic workshop normally. It's best done in person. You can do it remotely, of course. You tend to get a lot of different members from the business, both the technical side and the business side, in a room with way too many Post-it notes. And there's quite a chaotic scramble as you start to put events out on a wall, and then you start to consolidate them together. And event bridge storming is taking this a little step further, and as you tell from the name, very linked to AWS Event Bridge. How do we go from event storming to then start to build out the event schema in high detail, as in code, in something like TypeScript, and how do we start to define the services that are going to react to the events? After going through event storming, or event bridge storming, if you go a little bit further to start to add event bridge in the schema registry, you end up with something like this in your design. You're going to understand the set of services, your communication channel, and you're going to have your event schema defined. That's the event names and also the typing of the attributes in the events. And for teams that are adopting an event-driven architecture, the event schema, that sort of set of events and their typing, that is the interface between teams. We don't have APIs and synchronous request responses. That schema is how teams will communicate, and it also allows teams to work independently whilst using that schema as their shared interface. So we've gone through sort of the need for adding more agility into our migrations. We've seen that MVMs are sort of a framework for how we can do that, and how events are going to be underlying that. But the two other requirements we talked about were the ability for the existing system to emit events into the new system, and also the design of the new system to not be implicated by the constraints of the old system. And this is where we need an eventification strategy. And there are a couple of ways to get events from legacy. Some legacy databases, let's say using an old version of MySQL or Postgres, potentially you can get change data capture directly from database triggers. Application code triggers are also possible, and I've done this in a few projects. You can use the AWS SDK directly in, let's say, a legacy.NET application and publish events directly to something like Amazon Event Bridge. So you're making small code changes in the legacy for very significant business events, order placed, item dispatched, and they're directly going into Amazon Event Bridge, and then your new services and that new cloud-native event-driven architecture can react to them. That does require being able to code in the legacy system, being able to release in the legacy system, and there can be quite a number of places to add those triggers. And finally, you can do it at the log level. If you've got very good logging in the existing application or automatic logging from the existing application's database, you can do change data capture from that stream. But regardless of the eventification strategy that you have, we need to translate those very technical signals from the existing system into those very clean domain events of the new system. Now, of course, you can do that sort of ad hoc in different places, but the best way I've seen to do it is to adopt an anti-corruption layer. And this is a domain-driven design technique of how we can sort of translate between two different domains. Although these are both based off the same business, the same application, they're actually different domains because that first application was designed probably many years ago when the business maybe looked a bit different, and we've maybe hacked some stuff around to make that technology work for the domain that it is today. Also, that existing system was potentially, very likely, not built off domain-driven design from the business context, but maybe a more traditional approach was taken. So we need to convert between these two different domains. And if we centralize that in an anti-corruption layer, there is one team that has to handle that complexity of understanding the existing domain and also the design of the new system. And typically, engineers that have been working on the existing system for a long time are great people to have in that ACL team because they fully understand how the existing system works, will start to get onboarded into the sort of schema of the new architecture, and that's a really great transition into them moving into that new architecture. But the ACL is really transforming and translating, potentially aggregating, potentially caching multiple different signals to then aggregate to one signal, handling all that complexity, and then shipping those very clean events into the new event bus, which means that the services and the teams that are consuming those events or are being triggered by those events don't have to see that complexity, it's abstracted from them. With MVMs, we also need an injection strategy. The whole idea is we're going to rebuild, let's say, a hotel booking application, and we're not going to rebuild every step of it, but we're going to do different slices of that. So we need a way to inject our new code, our new experience, into that customer journey. Now, if it's a back-end only application, it's quite simple. We can do some redirects, we can add some routing into the legacy system, we can actually do it in whatever is calling, we can make that do the conditional jump between the two systems, or we can add some sort of proxy to intercept in between. Where it becomes a lot more interesting is when it's a full stack application. So that hotel booking system, you're going to land on a home page, see some locations, type in your location, the dates of travel, see a results page where you see all the different hotels, click one, probably try to be upsold many times, finally buy the ticket and get your email. There's many parts in that journey, and if we're not rebuilding everything before releasing, we need to be able to inject into that customer journey. So much more complex when it's front end, but micro front ends can be really useful in how we can do this injection and can actually be quite a great way to structure our teams to be able to work independently in the new architecture anyway. For those of you not familiar with micro front ends, as you can imagine, slightly inspired by microservices, it's a way of different teams to release independent parts of an application that then get brought together into one customer experience. And typically there are two distinct types of micro front ends. Horizontal micro front ends, where maybe you have the basket widget on an e-commerce page that appears on multiple pages of a customer journey, or vertical, which is really the page level. You say the home page is one micro front end. You then say the booking confirmation page is one micro front end. And with these micro front end strategy for injection, edge routing can be really useful. So typically, with many of the applications we've migrated, I've used edge routing in something like Lambda Edge, CloudFront Functions, Akamai Cloudlets. There are many different ways to do it in the CDN layer to redirect between the two different systems. And if we look at a few more graphical examples, let's say we've taken the vertical micro front-end injection strategy for our hotel booking application, and let's say the hotel lists page, so the list of the different rooms, let's say that's what we're going to migrate first for various reasons. So the home page, page one, that's in the legacy technology. Let's say we've got a page reload between the different pages. If you don't, there's a way to work around this. But for simplicity, let's say it's home page, you click, you go to the next URL. Well, actually, if we have edge routing and the ability to run code in the CDN as a request is coming through, we can actually just decide between the two different systems with a simple lookup table. Or actually, you can start to do more sort of gradual increase of traffic. So the first release of the room list page, we might want to release 10% of traffic or 15% of traffic because we want to test our assumptions and learn before we start to release more and more traffic, or maybe limit by geography or language. So the second page, that's going to go through, and the edge router is going to decide to throw that to the new system. And then the third page, let's say that's not been rebuilt yet, that's the payment page, and we don't want to deal with the PCI compliance. We can then have the edge routing drop that back to the existing system. With our vertical approach, it's a little bit more complicated. So let's say we've got a home page for the hotel booking system, and we've got some featured hotels. And let's say at the minute, that's a hard-coded list of hotels, and when the marketing team wants different hotels listed, they've got to contact the developers, make a code change. It's extremely annoying. In the new technology, we might be proposing a headless CMS like Contentful, and we might be allowing the marketing team to be autonomous. So that might be one of the key successes of the overall migration. We might be able to bring that very early in the project and test that whole flow of the CMS and how the team are going to adopt it by actually just injecting that part of the page to be a horizontal micro front end. So there are a couple of injection strategies for horizontal micro front ends. There's a really good book that recently came out, a new O'Reilly book on micro front ends. I'm not going to go into all the details, but you can do things like iframes, which are a bit clunky. The better way to do it, in my opinion, is to build an orchestrator, which is sort of a controller of the whole page. You bring in your legacy components, and then you override the DOM to drop in your new components. Or there are other ways where you sort of componentize or micro-frontify the existing system and then bring them together. But if you look up on micro front ends, injection strategies for horizontal, if you're into front end, there's a lot more complexity that goes there, but there are a lot of solutions. So we've seen the need to migrate. We've seen how we can bring more agility. We've seen eventification and ACLs to sort of enable our existing system to trigger events in the new system. And we've seen a number of injection strategies for those front-end applications. But now we need to decide, what are we going to migrate first? And typically, we're not going to, in serial, for a large application, have one team gradually cutting away at it, but we're probably going to have to run multiple teams in parallel and deal with the dependencies. So my sort of rule of thumb is that an MVM takes no longer than 8 weeks. I've typically found that teams are able to estimate quite well in 8 weeks and have a lot of focus and set clear goals. Outside of 8 weeks, I typically find that starts to level off. Obviously, 8 weeks is a rule of thumb, but that's what I try and drive our MVMs to be. They should relate to one and only one bounded context, let's say area of the system. We don't want to be involving multiple teams inside of the release of one MVM if possible, multiple sort of stream aligned, as Joel was saying in his talk, or multiple product teams in the release of one MVM. They should have very known dependencies and risk. They might rely on other MVMs, which creates a little bit complicated project phasing. And they might have risks. Let's say one of them involves card details. We're instantly adding PCI complexity into our migration. We should have a known return on investment. Of course, big migration projects often have very big numbers that people say they're going to bring to the company, but each MVM can bring something. That migration of the featured hotels page is going to bring something to the marketing team, a release frequency of changes to content or an increasing conversion. By setting targets on each 8-week MVM, the development team can actually be implicated in that. They can be excited by that, and they can also come up with better technical solutions to achieve that goal. And finally, of course, as we said, they need to be injectable, and we need to know the injection strategy. So this leads to what I call an MVM priority matrix. So we break down that aggregate application into a number of MVMs, and we need to know which domain they relate to, what the scope of the MVM is, what our injection strategy is, and what those dependencies are. Picking up a small example that I've sort of anonymized the top 3 MVMs from one of our e-commerce migrations, that might be a payment card for UK only as the payment domain, due to some PCI, adding that as a very high priority to be migrated from the existing system, taking that as a complete vertical micro front end, so as a whole page. That relates to the card payment feature, scope limitation of UK only to reduce risk, and also because multiple payment providers, it was an easy way to integrate one third party to start with, and the dependency being the Stripe integration layer, so integrating with Stripe into the system. MVM2, that is the search filters list, so being able to filter on the search results page of that booking website. That's a horizontal micro front end. It's appearing in multiple parts of the application, and other parts of that page were also going to be quite complex to rebuild all as one in such a short time period. So being able to split that and limit the scope, again, that is on the horizontal, so just one part of a page, means that it's shippable in those time periods. And finally, subscription payments, slightly more complicated than the existing payments. This is just an example. The features aren't that important, but sort of how to structure it and the things to think about. And although it might seem like there's quite a lot of overhead if we're going to, every small piece of the application needs to have this, I've really found that overhead, it might feel a bit intimidating at the start, but once you've got the orchestrator, the edge routing, the eventification, a couple of core pieces, actually splitting up isn't that complicated, and there's not much code overhead, just a bit of planning overhead. But I typically feel that planning overhead is on very short 8-week cycles. It's much better than the 18 months then finding out your architecture didn't work. So in conclusion, feature parity paralysis, I think, is what mainly leads migration projects to having these sort of big bang releases and being less agile. MVMs allow us to learn, test assumptions, and deliver value to our customers more quickly. MVMs also focus teams and really build that culture of delivery by shipping things to production every 8 weeks, not having that migration project that never ends. And MVMs are really those iterative stepping stones. They help us gradually move to that strangulation, and there probably isn't a final system and actually sets us up for quite an evolutionary architecture. Change data capture and an ACL can really provide us a stream of events from legacy, and that also being in the correct format, so not implicating the design of a new system with the constraints of the old system. Micro front ends and edge routings are really useful injection strategies if you're having to do a full stack application. And an event-driven architecture allows that clean interface between systems, but also is part of our migration strategy. And event storming and domain-driven design super useful to do, but really useful in defining that really clear interface for our new system, but also in the interaction with the existing system. And you can divide MVMs at different levels of granularity. This just impacts cycle time, how quickly you're getting these things out, but also the management overhead. If each MVM is 2 days, it's a bit crazy. 8 weeks seems to be the sweet spot we're hitting at the minute. Maybe it's 5 weeks, maybe it's 12 weeks. It depends on the MVM, the complexity, but aiming for roughly around 12 weeks seems to be working best with the teams I've been working with. I've written up more on the MVM stuff in a quick sort of PDF that goes through in more detail and more examples, hopefully releasing that in the next few weeks. So if you're interested in the topic, let me know and I can make sure I send you a copy. But other than that, very happy for any questions.
Thank you. Do we have any questions? I have one. I was just wondering, have you worked on something like this where somebody's tried to do a migration, completely failed, made it worse, and then you've had to come in?
Yeah, a couple of times. And the main reason why we started to come into companies that had taken on that big project. If you've read the Phoenix project, that kind of attempt, and then come in, and then we started to structure a much more iterative approach, and typically trying to get stuff to production. That's been the key thing on all projects, migration or otherwise, that I think motivates teams, but also reduces risk. And that drive to just get into production, putting some structure around that starts to get more buy-in from the existing teams to see the sort of plan rather than just saying, let's just ship something. They start to see this as iterative stepping stones. And I think the strangler pattern everyone relates with really well, but there isn't really that sort of step-by-step guide. So yeah, I think I've come into a few companies that have failed, and actually very sadly, often that initial migration becomes slightly throwaway, which is very painful for everyone. But as soon as you reset to this and you start to get stuff into production, motivation really jumps back up. But yeah, I've been in a few companies that have had to pivot from that approach back to this approach.
Okay, thank you. Any others? No? Okay, well, thank you. Oh.
I've seen a couple of cases, I think only a couple, where I've looked at someone's architecture and the concerns are separated nicely and you could migrate things piece by piece. Is this pattern suitable for where, is this pattern needed in a case where people's architecture just lends itself to migrating otherwise?
Yeah, I mean, if you're in the position to just lift and shift, it's really not applicable. If you're in the position where you've been doing beautiful domain-driven design and everything's split and it's all working very nicely, and maybe it's even event-driven, but maybe it's not event-driven in like this sense, maybe it's using an ESB or like something else, I think you can, if you've got a very good understanding of your domain and your constraints are purely performance or technical limitations, not the integral structure of the application or how the teams are working, yeah, I think just use what's definitely working. I'm typically seeing this apply where you've got very, very big teams on very monolithic applications, really struggling to get features through, having a lot of test fragility, having a lot of regressions in production. But if you have a highly functional team just limited by performance constraints of the underlying technology, I think, yeah, keep using what you're using and migrate that model of not only the technology, but also that model of how the teams are working.
Just to come back, I think
Sure.
The reason that I saw people migrating was our new cloud provider has written us a big check of credits.
So the question is, should you migrate if things are working?
Well, just to explain why people were migrating, there wasn't anything wrong with what they had, but the big
I was
check.
assuming you meant if they've got a great structure of teams and code, but it's more the technology, do they need to take such a complex approach? No, I don't think so. Use that model. If everything's working, they don't have the business needs to migrate in terms of performance, yeah, I don't think there's a good reason. But I think sometimes like the total cost of ownership and the fact that you don't necessarily see the complexity that you already have, that sometimes definitely is a factor, but migrating for the sake of it is not a good idea.
Okay, that's it. Okay, well, thank you. Another applause.
Thank you.